I need to be honest with you about something that just happened, and it's big. NASA discovered something today that completely changes what we thought we knew about this interstellar Comet 3 Atlas. And I'm not talking about just another data point or a minor update. I'm talking about evidence that this thing might actually be transforming right in front of our eyes. So, let me take you through what just came out, why it matters, and why the scientists who've been tracking this object for weeks are now sitting at their desks, staring at their screens, trying to figure out what the hell they're actually looking at. Because up until this morning, we had a story. It was a strange story, sure, but it was coherent. We were watching an interstellar comet, one that came from outside our solar system, doing some unusual things as it passed through. It was bright. It was active. It was losing mass faster than it probably should. But at its core, the assumption was solid. We were looking at one object, one nucleus, one comet, just spinning, venting, doing its thing on the way back out into the void. That assumption just fell apart. What NASA found in the newest data isn't just weird. It's the kind of thing that makes you go back and check your instruments, rerun your calculations, and ask your colleagues if they're seeing the same thing you are. Because if this data is right, and there's no reason to think it isn't, then 3 Atlas is not the same object it was a few days ago. Let me explain how we got here. For the past several weeks, astronomers have been watching 3 Atlas with every telescope they can point at it. Ground-based observatories, space telescopes, amateur setups, the works. And one of the key things they've been tracking is something called the light curve. If you're not familiar with that term, it's basically a graph that shows how bright an object appears over time. For a comet, especially one that's rotating, the light curve tells you a lot. It shows you how the brightness changes as different parts of the surface face the Sun and Earth. It shows you the rotation period. It gives you clues about the shape, the activity, the stability of the nucleus. And for 3I Atlas, that light curve has been pretty consistent. It showed one main brightness peak per rotation. Meaning, as this comet spun, there was one part of it that was brighter than the rest. And every time that part came around to face us, we'd see a spike in brightness. Then it would dim as the darker or less active side rotated into view, then bright again, then dim over and over, clean, repeating, predictable. That pattern told scientists, okay, we're dealing with a single nucleus here. It's got an irregular shape, sure, but it's one piece. One solid object spinning in space. The heartbeat was steady. Today, that heartbeat changed. When the team combined the latest measurements, pulled from multiple telescopes, and observing runs over the past couple of nights, they started processing the new light curve. And immediately, something looked off. Instead of that one dominant peak per rotation, there were now two. 2 brightness spikes, 2 pulses every single cycle. Now, if you're not deep into comet science, that might not sound like a huge deal, but let me tell you, in this field, that is a massive red flag because a light curve doesn't just change like that for no reason. If you go from 1 peak to 2, it means something about the physical structure of the object has changed. Either the shape of the nucleus has been altered dramatically, like something collapsed or shifted internally, or you're no longer looking at one object. You're looking at 2. And that's not the only thing. At the same time this light curve data was coming in, the imaging teams were finishing up their work on a fresh batch of high-resolution images. Now, these aren't the kind of images you see floating around on social media. Those are usually single snapshots, pretty blurry, not a lot of detail. What these teams do is they take dozens, sometimes hundreds of individual frames and they stack them. They align them perfectly pixel by pixel and they combine them to pull out every bit of signal they can. It's painstaking work, but it lets you see things that would otherwise be invisible. And when they stacked the newest images and compared them to the stacks from just a few days ago, they saw something that made them stop. The core of 3 Atlas, that bright central region buried inside the coma, the cloud of gas and dust surrounding the nucleus, it doesn't look the same anymore. It used to look like a single relatively symmetric blob of brightness, compact, centered, exactly what you'd expect from a single nucleus surrounded by a relatively even distribution of material. But now it's elongated. It's stretched. Not by a huge amount. This isn't some dramatic obvious split where you've got 2 distinct comets flying side by side. It's subtle. But when you measure the brightness distribution, when you fit the profile of that central region, it doesn't match a single compact source anymore. It matches something that looks more like two overlapping peaks. Two sources of brightness close together. So close that the cameras can't fully resolve them as separate objects, but far enough apart that the combined signal looks stretched, smeared. It looks like two nuclei, or at least it looks like one nucleus that's in the process of becoming two. Now, here's where this gets even stranger. The orbital analysts, the people who calculate the precise path this comet is taking through space, they released an updated orbit solution today. And buried in that update is another change that lines up with everything else we're seeing. They've recalculated the non-gravitational forces acting on the comet. Let me explain that for a second. When a comet gets close to the Sun, it heats up and ice on the surface turns into gas. That gas shoots off into space, carrying dust with it, creating jets. Those jets don't just make the comet look pretty. They actually push on the comet. It's like a tiny rocket engine. And that push, even though it's small, affects the comet's trajectory. Over time, it can shift the orbit in ways that gravity alone wouldn't explain. So, when you're calculating a comet's orbit, you have to account for these non-gravitational forces. You have to figure out how strong they are and what direction they're pushing. For 3I Atlas, up until today, that push had a pretty clear direction. The jets were venting from one dominant area and the rocket-like force was pointing in a consistent direction. You could plot it. You could predict it. In today's updated solution, that direction has changed. Not by some crazy amount. It's not like the thing flipped around completely, but it rotated enough that the direction of the thrust no longer lines up cleanly with the main jet structures that we've been seeing in the images. The comet is being pushed in a slightly different direction than it was before. So now let's put all of this together. The light curve says the brightness pattern changed. One peak became two. The images say the inner structure changed. One bright core became elongated. Possibly two overlapping sources. The orbit calculations say the direction of the outgassing thrust changed. The jets are pushing in a new direction. And all of this happened at roughly the same time. That is not normal. That is not what a stable comet does. Comets can be unpredictable. Sure, they can have outbursts. They can flare up. But this kind of coordinated change across multiple independent measurements, all pointing to a fundamental shift in the object structure, that's rare. That's the kind of thing that makes scientists sit up and pay very close attention. So, what's actually happening here? What did 3 Atlas just turn into? There are a few possibilities, and none of them are simple. The first scenario is internal restructuring. Imagine this comet's nucleus as a chunk of ancient ice and rock that's been sitting in interstellar space for millions, maybe billions of years. It's cold. It's stable. Then it comes screaming into our solar system, swings close to the Sun, and suddenly it's being heated for the first time in ages. The ice inside starts to melt. Some of it turns to gas and escapes. Some of it refreezes in different spots. The internal structure shifts. Voids form. Material moves around. If something like that happened, if a big cavity inside the nucleus collapsed, or if a chunk of ice melted and redistributed the mass, that could change the way the comet spins. It could change the wobble. It could change which parts of the surface are active. And all of that would show up in the light curve as a shift from one peak to two. It would also explain the elongated appearance. If the shape physically changed, if it got stretched or deformed, that would show up in the images. And if the active regions moved, the jets would start pushing in a different direction. So that's one explanation. The comet is still one piece, but it's been internally restructured by the heat and stress of its close pass by the Sun. But there's another possibility, and it's the one that has everyone on edge. Fragmentation. Not the Hollywood version where the comet explodes into 1,000 pieces in a spectacular fireball. Real fragmentation is slower, quieter, more insidious. What happens is the nucleus, already weakened by internal stress and outgassing, starts to pull apart. Maybe there's a crack that's been there for a long time and the thermal stress finally widens it. Maybe the spin rate increased just enough that centrifugal force started to overcome the weak gravity and structural integrity holding the pieces together. Whatever the cause, the nucleus begins to split. At first, it's not obvious. The two pieces are still close together, maybe only a few hundred meters apart, maybe less. They're still surrounded by the same coma, still venting gas and dust, still traveling on nearly the same path. From a distance, it still looks like one object. But if you look closely, if you measure carefully, you start to see the signs. Two brightness peaks in the light curve instead of one. Because now you've got two separate rotating bodies, each with its own active regions, an elongated core in the images, because you're seeing two nuclei close together, not quite resolved, but far enough apart that the combined light looks stretched. A change in the net thrust direction because now you've got two bodies venting, not one, and their combined jets don't point in exactly the same direction the single set of jets used to. If 3 Atlas has started to fragment, if it's pulling itself apart, then what we're seeing today is the first clear observational evidence of it. And that would be huge because we've seen comets fragment before, but never an interstellar one. Never one that came from another star system potentially with a different composition, a different internal structure, a different history. And remember, this comet has been riding the edge from the start. The rate at which it's been losing mass, throwing off gas and dust, has been extreme, way higher than what its size should allow. It's been burning through its reserves like it's in a hurry to destroy itself. Scientists have been commenting on that for weeks. If it's been that unstable, that active, then fragmentation isn't just possible. It's almost expected. Now, before we go too far down that road, there's a third possibility, and it's less dramatic. Please like, subscribe channel.